Hello. So welcome to our revision class for chemistry. So today you might see, these are possible questions you might see. So we're going to handle it today. It might not come exactly like this, but you might see something nearly as this. And we do it in two ways. We are going to handle this question in two ways. Okay?
Yes, sir.
So let's see what the question says. So let's see. You say A is a solution. I told you the A stands for the acid. So tomorrow you are going to see two round bottom flags. They will label one A, they will label the other one B. The B is the base. And I've told you what the acid is. The acid is H2SO4. Say A is a solution of H2SO4 containing 4.8 grams in 5 cm cube of solution. Say B is a solution of sodium hydroxide of unknown concentration. Question A now, put A into a burette and titrate it against 20.0 or 25.0 cm cube. Portion of B using methyl orange as indicator. So replace the titration to obtain a concordant titer value. Tabulate your readings and calculate the average volume of acid used. Now, if you can do your titration correctly and calculate the average volume of acid used, you automatically have 10 marks. You automatically have 10 marks. Okay? Victor, let me ask, have you been told the endpoint yet in your school? Hello, Victor?
No.
Okay. So the endpoints we are using is 12.20 cm cube. So what we're going to do now, we're going to answer the question A. Say put A into a burette and titrate it against 20 or 25 cm cube portion of B using methyl orange as indicator. Say repeat the titration to obtain concordant titer values. Tabulate your readings and calculate the average volume of acid use. So let's answer the question A now. So what I will do now, I will write, like I said, you must do this. If you don't do this, you are going to lose 3 marks. I will write volume
Volume of pipette used.
Pipette used. Or you write volume of pipette used. If you go back to the question, you see there are two values there. 20 or 25. I told you we are using the 25.
25.
Yes, so you write 20 equals to 25.00 cm cube. cm cube. You must put the units. You now write indicator used, indicator
Methyl orange.
used is equals to methyl orange. You must take these two expressions. They must be well stated. Then after which, you now draw your table at the bottom of this statement. You draw your titration table now, like this. You draw your titration table this way. Okay? You draw your titration table in this manner, like this. So you write titration. Here you put rough. Here you put first titer. Here you put second titer. Here you put third titer. Okay? Then after which you run another column, you write final burette reading. Final burette reading. Then you must put the units, centimeter cube. You must put the units. Final burette reading, cm cube. You draw another one. This will now start from initial burette reading is cm cube. Okay? Here you now put volume
of acid
of A. You can write it as A. You can write it. You can also write it as acid used in cm cube. This is what you must do. What I think you are taking off, taking note of volume of prepared use, indicator use. You take note of these two things first. You must state them because each of them have marks. Then you must write your table in this manner with your ruler. Don't use hand to draw your table. So you must go to the school tomorrow with your ruler and draw your table in this manner. Very neat and decent. So,
yes.
So remember, I told you that the capacity of the burette is 50 cm cube. So I will start my final as, I can start the final as 50.00. Now I've told you what the endpoint is. The endpoint is what? 12.2.
Yes.
So your target is to increase the rough to be more than what you are looking for. What you are looking for is 12.2. So you can increase it by a factor of 0.1 or a factor of 0.2. You can increase the rough by a factor of 0.1 or a factor of 0.2. So here I will write 12.30. Okay, because that's what my target is 12.2. So increase the rough a little bit. So how do you not get the initial? You say 50 minus 12.2. So 12.3. You now write 37.70. Now, all your values, pay attention to this. All your values must be to 2 decimal. All your values must be to 2 decimals. So that's why I'm putting 0 there inside. So here, I'm not come to what I'm looking for now. The first title, I can also start with 50 if I want. 50.00. What I'm looking for now is 12.20. So here will be 37.80. You see that? So I cannot take my second title. I can use 40 if I may want. If I want, I may use 40. 40.00. What I'm looking for is 12.20. So I will now say 40 minus 12.20. That will give me 27.80. So here, if I want, I can say let here be 45.00 if I want. So my target is 12.20. I will do it again, 45 minus 12.20. That will give us 32.80. Is it understood?
Yes, sir.
Victor, is it understood?
Yeah.
Huh?
Yes, sir.
Okay. Now that you have done this, let's go back to the question so that you see what I'm saying. Let's go back to the question. You go back to the question says what? Tabulate your readings. Tabulate your readings. That's what we just done. This is what I've done by saying tabulate your readings. Now, if you go back again, say calculate, look at it, calculate the average volume of acid use. So I have to do that now. So how do you calculate the average volume now? You are going to use these 3 values. Your interest is based on these 3 values here. These three values, that's where your interest lies. That's what you use to calculate the average volume of acid use. So I would say the average volume now, which is my VA. The average volume, I write it as a VA. Average volume of the acid now becomes V1 plus V2 plus V3 divided by 3. So my VA now will be what? So I will consider the first V. What is the first V here is this, 12.2. Second V, 12.20. Third V, 12.20. So I will have 12.20 plus 12.20 plus 12.20 divided by 3. If I add up, that will give me 36.60 divided by what? 3. So if you divide it, what will you have? I'm going to have 12.20 centimeter cube. You can see, this is what you are looking for. At the end of the day, we got it back. Is it clear?
Yes, sir.
Victor, is it clear?
Yes, sir.
Okay, write the question first. First of all, write the question, so that you can study with it later. If you don't, let me know, so I can go back to the table and so you can write it also.
Bye.
Making progress with the question. Are you done writing the questions?
Me, I'm done.
Victor, are you done?
Yes, I'm done.
Okay. Now we have answered question A. So write the table now of the question A. Now copy this table of question A. Now you can write exactly this table tomorrow if you want, or you can form your own using 12.2 as your endpoint, or you can write exactly this thing tomorrow. You choose to write this in exactly this thing, or you form your own using 12.2. It's the same thing. Are you done?
Yes, sir.
But are you done?
Yes, sir.
Okay. So then calculate the average volume now. Your VA.
I'm done.
Okay. But are you done?
Yes.
All right, let's go back. So this is what is expected you to do with question A. If you can do this correctly tomorrow, you have your complete 10 marks. Starting from volume of pipette use, indicator use, then the table. You have your complete 10 marks. Now, the second question for the reaction is this. This is the acid, H2SO4, this is the base. How many more of the acid reacted? 1. How many more of the base reacted is 2. So take note of that. So the mole ratio of the acid to base is 1:2. Take note. So say from your results and information provided, what are the information provided? Let's go back to the question to see the information provided. Let's see now. So the information provided is this. It says a solution containing what? 4.8 grams. That is one
4.8
information.
gram.
Then they gave us in what? 500 cm. That's another solution, on that information. Then they still give us volume of the pipette, another information. And say from your result, what is the result you have? Is the volume of is your average titer. This is your result now. The average titer is your result. Are you there? Which is 12.2. So take those. So from your result and information, the result is of 12.20. The information is the 4.8, 525. So let's see what to do from here. Question B now. Let's see what the question asks us to do. Question say, is calculate the concentration of A in mole per dm cube. Now, I want you to take note of something. Concentration is of two types. We have concentration in mole per dm cube, and we have concentration in grams per dm cube. The concentration in mole per dm cube is called molar concentration, while the concentration in gram per dm cube is called mass concentration. Are you there?
Yes, sir.
There are two concentrations, whether we have molar concentration or we have mass concentration. Molar concentration is mole per dm cube. Mass concentration is gram per dm cube. Now, how do we find the molar concentration of the acid? Now, let's read the information containing the acid. The acid contains what? 4.8 grams in what? In 500 cm cube. Okay? So anything that, take note of this principle. Anything that have mass must have a molar mass. Since the acid have a mass of 1.8, I must get the molar mass of the acid because the acid has a mass. So I will start by first of all calculating the molar mass of the acid. So I will say molar mass of who? Of the acid, H2XO4. So I'm going to have 2H, because these two belong to H, plus X plus 4O. This is how you calculate molar mass. 2H plus X plus 4O. Now, if you go back to the question, they gave us atomic masses. Look at them. They gave us atomic masses from the question. You can see here, you can see hydrogen is 1, oxygen is 16, sodium is 23, sulfur is 32. You see it, they gave us atomic. So anywhere I see hydrogen, I'll put 1. Anywhere I see sulfur, I'll put 32. Anywhere I see oxygen, I will put 16. So that's how that will give now 2 times 1, because hydrogen is 1, plus sulfur is 32, plus 4 times 16, oxygen is 16. So if I multiply, I'm having 2 plus 32 plus 64. That will give us 98 grams per mole. You must state the correct unit. You must state the correct unit. If you state the wrong unit, they will give you -1. It's -1. So you must state the correct unit. The unit of molar mass is grams per mole. So now that I've gotten the molar mass, I can now find the concentration, which is Roman figure 1 now. I will have, the formula says is given mass over molar mass. That is the formula. Given mass over molar mass is equals to volume over 1000 times your molar concentration times molar concentration. Molar concentration. You get that? So what is the given mass they gave to us? Let's go back to the question. What is the given mass? According to the question, given mass is let's see. Look at it here. The given mass is what? 4.8. The volume is what? 500. We have already gotten our molar mass already. Okay, so let's substitute them. So I'm in place of given mass, I'll put in 4.8. Molar mass calculator is 98. It's equals to volume is 500 over 1000 times your molar concentration. Okay? In chemistry, if you are doing chemistry, you don't put this sign like this. This sign of cross multiplying. Don't try that in chemistry. If you do that, it's -1. Is that clear?
Yes, sir.
Victor, are you listening? If you do that in chemistry, is what? It's -1. So you yourself, you know you are cross multiplying. So I will write 98 times 500 times molar concentration, molar conc, is equals to 4.8 times 1000. So you know you are cross multiplying. So, but don't put that sign. So what will now be my molar concentration now? So my molar concentration will be 4.8 times 1000 divided by 98 times 500. So multiply the up and tell me what you have. 4.8, let me multiply from here. 4.8 times 1000. Don't divide once. Make sure you multiply and write that the value. Here will give you 4,800. Then 500 times 98. That will give me 49,000. This is what you must do. Don't multiply and divide once. I will now press it 4,800 divided by 49,000. It's going to give me, so my molar concentration now will give me molar conc of A, of the acid now. This of A is now 0.098. Okay? You put the unit mole per dm cube. Put the unit mole per dm cube. Is it clear?
Yes, sir.
Victor, is it clear?
Yes, sir.
Okay. So write it first. Write this one first before we proceed. Write this.
Stop that. No, come on.
I'm done.
So are you done?
Yes, sir.
Okay, next page.
I'm done.
So are you done?
I'm almost done.
Okay, hurry up. Let's make progress.
Okay, I'm done.
Okay. So let's make progress to question. Let's see question Roman got 2. What does it say? Roman got 2 questions says Roman got 2 says we should calculate the concentration of B also in mole per dm cube. We have gotten the concentration of A already in mole per dm cube. They are not asking us to calculate the concentration of B in mole per dm cube. Now, pay attention. Anytime you have one concentration, listen to this thing. Anytime you have one concentration and you are asked to calculate another concentration, this is the formula you must use. Roman got 2 now. Anytime you have a concentration and you are asked to find another concentration, here's what you must use. CA VA over CB VB is equals to NA over NB. So what's my CA now? The concentration of the acid we calculated. We got was 0.098. Abi? Mole per dm cube. You have to write them out. The concentration of the base now is what I'm looking for. I don't know. What is the volume of the acid? VA is what? Is your endpoint 12.20 cm cube. What is the volume of the base? That is the volume of the pipette is what? 25.00 cm cube. Are you seeing it?
Yes, sir.
So what is my NA? I have to go back to the equation. My NA is this one. My NB is this 2. Its number attached to the acid is 1. How many number is attached to the base is 2. So my NA is equals to 1 and my NB is equals to 2. So anytime you want to use the formula, you must state all this data out. Is that clear? You must state them out. So I'm having, let me substitute them now, 0.098 in place of CA. My VA is 12.20 over my CB is what I'm looking for. My VB is the volume of the pipette is equals to 1 over 2. Like I said, it is forbidden for you to put this sign like this. But you and I know we are cross multiplying, is it not? So I will write
Yes, sir.
CB times 25.00 times 1 is equals to 2 times 0.098 times 12.20.
Because I've given you what you want now.
Are you there? So I will now make CB the subject formula. So my CB now will give me 0.098 times 12.20 times 2 divided by 25.00 times 1. Like I always say, don't multiply once. Multiply the numerator and write it down. So I will have 0.098 times 12.20 times 2. I will write the value. I'm having 2.3912. 25 times 4 give us 25.00. I will not divide by 25. The answer is 0.095 mole per dm cube. That's not the concentration of the base. Like I said, anytime you have a concentration in mole per dm cube, and you have to find another concentration in mole per dm cube, this is the formula you must use, the general formula. So right, before we make progress to the next question.
Please, I understand you tell me what you are saying there. I think if you read this book, I come and tell me this. So from nothing Friday. This book that I changed there is 800. I want to see when you finish even reading it, any other person can take it and be reading it. So it's very good, so everybody can read it. Even me also I will read. I won't be that they bought it for read it. What you say, your exam is coming.
So you mute yourself for a while. True. Both of you let me know.
I'm true.
Are you true?
I'm not done yet.
Okay.
Okay, I'm done.
Okay. Give me a minute.
Yeah.
Idea book. Eh? Yeah.
I want to book Bible at the time.
Oh.
Wait, so then that only you can put this soup inside freezer. Eh? And what for your Nara to tell you put it. And what for if that soup.
Let's go to Romans figure 3. Let's see. Okay, Romans figure 3 say what? It says calculate the what? Concentration of B in what this time? In grams per dm cube. I told you earlier we have two concentration. One is in mole per dm cube, one is in grams per dm cube. So we are looking for the concentration of the base now. This stands for the base in grams per dm cube. So how do we calculate concentration in grams per dm cube? It has a mathematical relation. Mathematical relation states that mass concentration now, which is the concentration in grams per dm cube, mass concentration is equals to molar concentration times molar mass. Okay? So we have calculated the molar concentration already of the base as what? 0. Look at it here, 0.095, Abi? So that is the molar concentration, which is this value here. What about the molar mass of the base? I need it. So I will now find the molar mass of the base and molar mass of who? Of sodium hydroxide. Sodium hydroxide is the base. This will give me what? Na plus O plus H. And what is the atomic mass of sodium? 23 plus 16 plus 1. That will give us what? 40 grams per mole. Like I told you, if you write a wrong unit, it will attract -1. Are you following?
Yes, sir.
So now that I've gotten the molar mass now, let's find our mass concentration. So mass concentration now, mass conc of who? Of B is equal to the molar concentration we got as 0.095 times what? Times 40. So multiply, what am I having? Now press 0.095 times 40. That will give us 3.8 grams per dm cube. That's how to find mass concentration. It's the molar concentration times the molar mass. At the end of the day, we're having 3.8 grams per dm cube. Is it clear?
Yes.
Write it.
read the book Bible.
I'm done.
Are you through?
I'm not done.
Okay.
I'm done.
Okay. So let's look at what the last question says. Let's look at what the last question says. Which is Roman figure 4. Right? Roman figure 4. Let's see. He said, calculate the mass of sodium sulfate, mass of this one now, the mass of this thing here. Sodium sulfate, which is the product, form if 250 cm cube of sodium hydroxide we are neutralized. Now remember I said something earlier, that anything that has mass must have what? A molar mass.
Yes.
So since they're asking for the mass of sodium sulfate, that means I must calculate the molar mass of what? Sodium sulfate. So I will start by saying molar mass, figure 4 now. Start by saying molar mass of sodium sulfate. Molar mass of Na2SO4. So give me what? 2Na plus X plus 4O. That's what we have. Isn't it? So this will give me 2 times 23 plus 32 plus 4 times 16. That will give me 46 plus 32 plus 64. What are we having? 46 plus 32 plus 64. That will give us 142. Here we go again, the unit, grams per mole. That's the unit of molar mass. So now that we are looking for the mass, according to the question, we are looking for the mass. They gave us the volume. We have the molar mass already. Okay, and of who? Of sodium hydroxide. What is the concentration of sodium hydroxide? Let's go back to it. What is the concentration of sodium hydroxide? Which is our CB. Our CB was what? Look at the value here. So we're going to use that concentration because we're talking about the sodium hydroxide. So we are concentrating on the concentration of sodium hydroxide in this case. Is that clear? Is it clear?
Yes, sir.
Hello, can you hear me?
Yes, sir.
Yes, sir.
Okay. So I'm looking for given mass. I will write GM. The G is the given, the M is the mass. Over the molar mass I calculated 142. Because the volume is what? 250 over 1000 times molar. No more molar. We have a value for it already. And the value is what? 0.095. You see that? So if I can't multiply now, like I said, this sign is forbidden. So if I simplify further, I'm going to have given mass times 1000 is equals to 250 times 0.095 times 142. So my given mass now will be what? 250 times 0.095 times 142 divided by 1000. So given mass will give me what? So having 250 times 142 times 0.095 That will give me 3372.5 divided by 1000. Oh, what am I now having? Divided by 1000. That will give me 3.3725 grams. Like the unit of mass is grams. Is it clear?
Yes, sir.
So write the solution.
Done.
So yeah, are you through? Are you through with this page, page 0?
I said I'm done.
Okay.
Yes, ma'am.
But I still using my calculator which I told Eh? What about me? I'm writing. What you're writing now is writing. I want if you put
I'm done.
Okay.
I'm done.
Okay. So you might see the question in this manner. You might see it in a different form. This is one step. I get what I'm saying, Victor? So what happens if they give the question in a different form? How do you approach it? Whatever they may give, whatever form they may give the question, what does not change? What does not change is this table. In whatever way they set the question, this table does not change. It remain as this forever. It remain as the endpoint remain as this. Do you understand?
Yes, sir.
Is it clear?
Yes,
Yes,
sir.
sir.
That does not change. You must have 12.20 as your endpoint. So before we proceed to the second way of solving it, let's take the question 2. Let's look at question 2 first. Look at question 2. I want you to also write it, please. Write question 2. Question 2, there's 90% chance, this is how you will see the question 2. I can assure you that there's 90% chance, this is how you will see the question 2.
you are not.
Good luck.
Sir.
Okay.
Good evening, sir.
Well, let me introduce you. I have okay, you met Vijay before. I have another student here, Victor. He's also in the class, okay? So we are dealing with question 2 now. We'll reverse question 1 with you later. I will do it a different form. Then we'll revert it formally. So copy the question 2. They are copying it right now.
Okay.
There's 90% chance this is how you will see the question. 90% chance.
Okay. I'm done.
Okay. Are you guys done? Victor says done. I'm waiting for Fidjuri on the. Good luck.
Okay, I'm done.
Okay. Good luck. Are you too?
No.
Okay. Good luck. Are you true?
No, sir.
Like I was saying, there's 90% chance this is how the question will come. It might not come exactly like this. Like question B can be your question C. Your question D can be my question B. But this is what you will see. This is exactly what you are going to see. Are you done? Good luck. Good luck. Are you done? Hello, good luck. Good luck. Are you done? Okay, we're having network issues. So let's continue. Victor and the Fejuru. Okay, yes, he lost network before. I'm adding him again. So if you look at this question, it says C is a mixture of two sorts. Carry out the following exercise on C, record your observation, and draw your inference. Sometimes, in place of that inference, you may see the word conclusion. It's the same thing. So, who are these two sorts? Who are the two sorts? Let me just make it clear to you. The two sorts are, these two sorts, your C is lead carbonate. But you're not going to see lead carbonate, then they will label it as C. And or plus starch. These are the two materials you will see. Lead carbonate and what? Starch. So both of them are white. Both of them has white color. This is white, this is white. You all know starch before now. Starch is white, have you?
Yes.
So when they mix them together tomorrow, you might not know who is starch, who is lead carbonate. And we have a normal starch. And both of them, these two substances, they are insoluble in water. That means they don't dissolve in water, insoluble in water. These two materials. Are you there?
Yes, sir.
They're insoluble. So this is the first question you will see tomorrow. I can bet it with you. This is what you will see. Put C into a test tube and add 10 cm cube of distilled water. Stir the mixture thoroughly and then filter. Keep both filtrate and residue. This is the question you must get tomorrow, 100%. This is the question you must get tomorrow. Question 1A, Roman figure 1. This is how they will set it. Now, if they set it like this, that means Roman figure 2 must follow suit. We say test the filtrate with litmus paper. So let's answer question 1A, Roman figure 1 first. So you are going to draw a table like this. Like I said, you must use your ruler to do so. You write here test. You write the answer on observation.
Sir, is this the SWOT analysis?
Yes. Then lastly, you will now see inference. Inference. So this table, if you want to draw it, and you must do it very neatly with your ruler. Must do it very neatly with your ruler. Now, let's go back to the question. You see that question, A Roman figure 1. So it must not be A Roman figure 1. Question tomorrow can just be just A. So this is just what I just came up with. But this is how the question will look like. So I will write A now, Roman figure 1. So I will now say C plus 10 cm cube. This is how you write it. Distilled water. You put full stop. That's the first statement. They said distilled water. So what they say next? It says stir the mixture thoroughly, then keep filtrate and what? Residue. After that says stirred thoroughly and filtered. Stirred thoroughly and what? Filtered. This is how you present it. Now, remember I just told you that both salts, these two salts, are what? They are insoluble in water. Both of them are what? White. That means if I should add that 10 cm cube of water to it, the salt will not dissolve. Let me take for instance, have you ever added sugar to water or salt to water before? Have you ever done that when you add sugar to water? What do you see? The sugar dissolves completely in the water, right?
Yes, sir.
So it simply means that the sugar is soluble in water, meaning it dissolves in water. But in this case, now these two substances are insoluble. So I would say C partly partly dissolve. Partly what? Dissolve. Okay.
Yeah.
So he said you stir. When you stir it, no matter how you stir it, it will not dissolve. That's the essence of the stirring. You will not stir to ensure it dissolve, it will not dissolve. So you now say C, partly dissolve in water. Then after stirring it, they will now ask you to filter. What do you see? Partly dissolve in water, when you filter, you're going to see something colorless like water with a colorless filtrate. With a colorless filtrate and a white residue. So when you carry out the exercise, don't need to carry out because this is what you are going to see. I've done all these things in the lab. So it says C partly dissolve in water. It's also C partly dissolve with a colorless filtrate and a white residue.
They
So
wrote without.
Huh?
Wrote without.
I didn't hear you.
You wrote without.
Okay. It's supposed to be with colorless filtrates. Thank you for that. It's supposed to be with colorless filtrates. With colorless filtrates. With colorless filtrates and a white residue. So I believe you know what is a filtrate. What is a filtrate? Now, let me show you what a filtrate is. Have you seen where somebody filter rice before?
Yes.
We boil rice, now filter it, Abi?
Yes,
So
sir.
the water that came out from the filter, as you wash the rice, that's what we call the filtrate. Why the rice itself that remains in the filter is called the residue. Is that clear?
Yes, sir.
Okay, so what is that my inference? I will not say C is a mixture of two salts. C is a mixture of what? Two salts. That is not my inference. Or C is a mixture of two insoluble salts. You can also use that. C is a mixture of two insoluble salts. You can also write that as your inference. Is that clear? So Ipo should write this. After we should go to the next question.
So I'm done.
That's finished?
Me.
Okay, so all of you are
I'm done.
finished. So let's go to a quick question. What the remark box says. Test filtrate with what? With litmus what? Paper. Like I illustrated, when you filter rice, the water that came out from the rice is the filtrate. So you have to test the filtrate now. You now use litmus paper to test the filtrate. There are two litmus paper. We have red and blue litmus paper. Do you understand?
Mm.
You have to test the filtrate with both of them. So let's go to that page now. So the same table, now I'm continuing. No, it's a continuation. So no need to draw another test, observation, and inference. I'm continuing. So I will now say filtrate plus what? Litmus filtrate plus plus litmus paper. Now say filtrate plus litmus paper. Okay. So when you test with the blue with litmus paper, you're not going to express anything. But we test with the red molecule, the red molecule will change to blue. Now say filtrate turn red litmus paper blue. Filtrate test turn red litmus paper what? Blue. So what will be my inference now? Filtrate contains alkaline solution. Are you there?
Yes, sir.
Filtrate contains what? Alkaline solution, because it's only base that turn red litmus to blue. So if you turn the red litmus to blue, that means that solution is alkaline. That means it contains base. Is that clear?
Yes, sir.
Yes, sir.
Right, you must go 2.
If you still put it as filtrate is a base, would they give you the mark?
They will not give you the mark. There are different types of base. We have weak base, we have strong base. So which base are you talking about? So that's why they use the word alkaline. Okay, the word base is alkaline. It's something that is soluble in water. Okay, it's something that contains water, alkaline. Because you added water to the solution, Abi. Alkaline is something that contains water, so you cannot say base. Base does not contain water. So that's why you use the word alkaline solution.
I'm done.
Okay.
Okay, I'm done.
Okay. Look, good luck. Are you done?
Yes, sir.
Okay. So let's go to Roman figure question B. We have done with A now. Now it says to the first portion of, okay, what you write here, don't write change the filtrate to the first portion of solution C. Change it to solution C. Remove our filtrate. So the first portion of solution C, add 2 cm cube of sodium hydroxide in drops and then in excess. Change it to the first portion of solution C. Remove filtrate. To the first portion of solution C. Have you done that?
Yes.
Okay. So, first portion of solution C plus what? Sodium hydroxide in drops, and what? In excess. So how do you present that? So the same table, we are continuing. No need to write test observation. We are continuing with the table. Don't write a different table. So I will not say question B now. Then I put B. Portion of solution C plus sodium hydroxide. Okay, you put aqueous, in drops, then in excess. This is how you present that statement. So what will I observe? I'm going to observe a white shocky. It look like shock. White shocky. I don't know if you have seen where they dissolve shock in water before. When you dissolve shock in water, you hold the shock, it will look like it will stay in your hand and we that's how the solution will look like. White chalky PPT form. Okay, white chalky PPT form. So that's when you add it in. You can put it in drops. Full stop. Then what about the essence? You now say PPT soluble, or some people can use the word dissolve. Soluble or dissolve in excess. Okay? Soluble or dissolve. So what's that my inference? There are three things you must write. The first one is lead, Pb2 plus, comma, aluminium, 3 plus, then comma, zinc 2 plus. You write present. Okay? You write present. Is it clear?
Yes, sir.
Yes, sir.
No,
Okay,
where's
write
your
it.
students? What's the students? What is your students?
Okay, write that.
I'm done.
Okay. Pedro and good luck. Are you done?
I'm
Yes, sir.
almost done.
Okay.
I'm done.
Okay. So let's go back to question B, Roman go 2. He said, to the result solution, add 2 cm cube of ammonia, NEH3 sulfur ammonia in drops, then in excess. And then warm the mixture and allow to cool. Okay? Warm the mixture and allow to what? To cool. So how do you present it? I will not draw a different, like we are still continuing with the table, nothing change. Continuation. So I will not say, what we got 2 now? Solution C plus 2 cm cube of NEH3 in drops, then in excess, plus what? Heat. Okay? So although there are 2 conditions here, pay attention. You might not see the plus heat, but if they want to stress you, they will ask you to heat it and allow it to cool. Do you understand? So what are you going to see? I'm still going to see white PPT form in drops. Okay? Then PPT insoluble in excess. Okay? PPT what? Insoluble in excess. Then, like I said, they can ask you to heat the mixture. When you heat, this is what you are going to see. PPT dissolve on warming. And reappear on cooling. You see that? So for each case, for each of the statements, I make a case for them. Solution C plus sodium hydroxide in what? In drops. Look at the case. Why PPT form in drops? I make case for that. I get it. This is how you do it. Then in SS, I also make case for it. PPT insoluble in what? In SS. Plus heat, I make case for it. PPT dissolve on heating, on warming, and reappear on what? On cooling. Are you getting it? You have to make case for each of them. So what are we seeing here? PB 2 plus present. Like I said, you might not see the you might not see the plus heat. If you're not seeing the plus heat, that means this part will not be will not be part of it anymore. That can only be part of it when you heat it. Is it clear?
Yes, sir.
Okay, write that.
I'm done.
Who else has finished?
I'm done.
Okay. Good luck. What about you?
Yes, I'm done.
Okay. So well done. So let's go to Roman figure 3. So you might, like I said, if they want to make the thing complex, you might see option 3. Set to the solution into add 2 cm cube of what? Iodine solution. So what are you going to have? Like I said, you should draw a table. Okay, so I will say solution C plus 2 cm cube of iodine solution. Cm cube of iodine what? Solution. So what I'm going to see is a yellow PPT form. So in this case now, it means that you also write PB2 plus present. Like this one tomorrow is other probability. You might see this one, you might not see it. But so that's why I make the whole thing. I just test for everything. So that any I comes, you can answer it. So write that.
Yes, sir. I'm done.
Are you done too?
Yeah.
I'm done.
Victor, are you done? Victor, are you done?
I'm done.
Okay. So we are going to question C. Zero mark on 1 cell. The second portion of solutions associated to solution C. And so sorry, hold on. If you are using this, that means you also heat it, plus heat. Add plus heat. That's the only way you can explain this thing. Add plus heat. Add plus heat to that. Okay?
Yes, sir.
So it says to the second portion of solution C, add 2 cm cube of iodine. So I will draw a table for the same table. I'm out of this just to extend it. So I will now say solution C plus 2 cm cube of iodine. You can see this time around we are not heating. Are you there? We are not heating. So you are going to see blue, black coloration. Blue, black coloration form. So what's not the inference? Presence of starch. Presence of starch. Presence of starch.
President pursue government from the country.
So,
When do you think going to pursue from Nigeria? When you can pursue? When do you go to Lagos?
I'm done.
who else has finished? Are you around the good look? Are you finished?
Yeah, I'm done.
Yes, sir.
Okay. So let's go to question. Okay, that's okay. The same thing. Question. Let's go to question D now. You said to the residue, add 2 cm cube of. There are two things you may ask you to add: either dilute nitric acid or dilute ACA. These are the two things you may ask you to add. So now, who is the residue? Like I told you, I used rice to illustrate the example that time. The rice that is remaining on the filter is the residue. So to that rice, now you say you should add 2 cm cube of dilute nitric acid or dilute ACA. So how do you present that? Present it this way. So this is my test. Okay, no need for that. I've gone through that process before. So the same process. So I will have residue plus 2 cm cube dilute ACA, or you may ask you to use dilute HNO3, the same thing. The result will be the same. Okay, the result will be what? The same. So what we do that? What are we going to see? We're going to see evolution. Also, people use the word effervescence. Okay, of a colorless and odorless gas. Okay, you may see evolution of colorless and what? Odorless gas. So there are two gases that have this property. It's only two gases that can exhibit this property. Who are the two gases? It's carbon dioxide. You now say CO2, hydrogen also is a bigger property present. Okay. So it's only two gases that are colorless and odorless, which is hydrogen and the carbon dioxide. So you now say CO2, hydrogen present. Is that clear?
Yes, sir.
Okay. Right.
I'm done.
Who else has finished?
I'm done.
Okay. Victor, are you through?
Yes.
I'm done.
Okay. So let's go to the last question then. You say, pass the resulting gas into what? Lime water. So I will not have, I will have 0 Roman figure 2. I will say resulting gas plus lime water. Okay? Are you there?
Yes,
So
sir.
what's the observation? You want to say gas, turn lime water, gas, turn lime water, milky. So remember, we said there were 2 gases that have this property. So if the gas turn lime water milky, meaning this one is not the gas is not hydrogen, the gas is a carbon dioxide. So if you turn it milky, so it means that it's CO2 gas from CO3 2 minus. Or some people will write, place of that CO3 2 minus, and some people might write HCO3 minus. Is that clear? Any of you can solve.
Is that down? Is the CO3 minus that stuff? Is it really necessary?
Yes, it's very important. Very, very important. Very important. So this is the last part. Like I said, there is 95% chance. This is how you will see the question tomorrow. 95%. You might not see the way we arrange it, but this is how you will see it. You might, the last one might come first, second one might come last, just like that, but this is how you will see it. Is that clear?
Yes, sir.
Okay. Okay. So this is sort of like question 3. They can set any question from chemistry in number 3. Any question at all can be your question 3. Is that clear? Any question at all can be your question 3. So as far as the entire textbook is concerned, can be your question 3. So this is all we can take tonight. Okay.
Yes, sir.
Good luck. Are you able to? Are they giving you the range of the endpoint?
No,
Did they give it to you?
no.
Okay. So the endpoint you are using tomorrow is 12.20.
Yes, sir.
Victor, you are the same thing. Pedro, the same thing. I'm sure you have to construct the table using 12.20. So you do that. Understood?
Yes, sir.
Yes,
So
sir.
good luck. I will send you the first recording we did. So you go through it.
Okay. Yes, sir.
So what's the first part? Because I have another class coming up with somebody else. But if there's time, I may communicate with you so we can redo that calculation again. Understand?
Okay. Yes, sir.
All right. So all of you take a good luck. Write well tomorrow.
Yes, sir. Thank
Victor,
you.
write well tomorrow. Fejiro and good luck. So take care. Study this thing properly. This is how you see this person tomorrow. Study it properly.
This question was
All right. I'm logging out.
Yeah.
what?
Eh?
I want to